Today we're going to be talking about system solutions and energy cost. Jeremy Lang is our presenter and our local GeoAnalyst guru, if you will. He's our TM from Iowa, so I'm going to turn it over to Jeremy and we're going to get going.
Thanks, Noah. Good morning, everyone. Thanks for sitting in on this webinar. I appreciate you taking the time out of your morning to do this. If you've got any questions, feel free to go ahead and type them in, and we'll try to answer them as the webinar wraps up. I'm also going to open it up for some Q&A towards the end. So that being said, let's get rolling. GeoAnalyst is our energy analysis program, and it's available at geoanalyst.net. You can purchase the program or try the program, and we're going to go ahead and just get logged in here. The first step to doing the GeoAnalyst report is a manual J load calculation. So this program does not do load calculations. This program is only for energy analysis or system selection, basically a simulator for the operation of that geothermal system. Once you get your heat loss and heat gain completed, you'll get something. I'm going to pull up another little chart here. You get something like this. This is a different program. Keep in mind, this is not GeoAnalyst, this little graph. So what I'm showing you here is that the heat load and the air conditioning load of this project are as such: 71,077 heating, and then here's your sensible and your latent cooling load for this project. So that's completed by another computer program or manual J longhand form, however you guys get your load calculations completed. That is step one. Step two is to open up the GeoAnalyst program and simulate your project. So here we're going to go with, let's go with GeoAnalyst Example. And this in is my location here. Just type a little bit of basic info in here. On your weather data screen, obviously I'm going to select United States, Iowa, and for this example I'm going to go with Cedar Rapids Airport. So this is the location of your project. When I type in this information here, this is simply for the user to read. It has no actual formulation or no actual function in the calculations. Down here on the weather data, that is where the system will be living or operating. So it's important that you actually use the drop-down menu and select something that's close to where your project is. Now we can go in here and add a system. This is going to be another geo system. So what you're going to see here is that I have two geo systems down here on the bottom of the page, System 1 Geo and System 2 Geo. I want to just run a comparison for you, and we'll maybe look at a 4, 5, or a 6-ton unit and see which one would be the appropriate fit for this project. And I'm going to go ahead and add in a propane system. We know that's a great demographic for us. Anyone burning propane, we can help them save quite a bit of energy. Now, for some reason, that stuff didn't save. I'm not sure why. But I can type pretty quick, so we'll get this rolling here. All right, so GeoAnalyst example, I've selected my city. I've got 4 systems racked up here. I'm going to do System 1, 2, 3, all geothermal, and System 4 will be a propane comparison. Next thing I'm going to do here, everyone notice that on the navigation tabs across the top, we have utilities, loads, economics, operating cost summary, payment analysis, graphs, print, and help. At any point you can click the help menu and get help. What I like to do is just go from left to right across this header, and we're going to hit utilities. Oh, that might be. So it wants a unique project name. That should do it. And we'll bounce out to utilities. So on this page, what we have is a lot of different rates for different utilities. The gray boxes are electric. It's full of, like a gas or a propane furnace, the electricity used to run the blower, the electricity used to run the air conditioner. That rate is put into these gray boxes, summer, winter, and escalation. If you can forecast the future, then you feel free to put some escalation in there. I prefer to keep it down at 0 because I like to use today's rates. So what we'll do is I'm just going to leave that at 10 cents a kilowatt there. Natural gas, 80 cents. It won't make a difference. We're not going to do a natural gas comparison today. LP, I'm going to put that at about $1.30. You can do fuel oil if you wish. For today's example, we're only going to do geothermal and propane. Over here in these green boxes, we have the geothermal rates. I'm going to leave that at 10 cents as well. So we'll keep it pretty fair. You guys can manipulate this. I realize in my own house, I pay 14 cents a kilowatt for the summer, and I only pay 7.5 cents for the winter on my Geo system. So if you have a program like that, you could input it right here. So my winter rate would be 0.075. My summer rate would be 14 cents, and that's going to basically log all my air conditioning runtime at 14 cents a kilowatt, all my heating runtime at 7.5 cents a kilowatt, just to show you for that example. But today, I do want to leave everything at 10 cents a kilowatt just to keep it clean. So on this blue box here, this is the electric rate for a Geo system with a fossil fuel backup. So that would be a dual fuel system. In some cases, the utility company will give you a better deal for a dual fuel system. Some cases, utility companies actually will give you a higher price electric rate for a dual fuel project. So this depends on your region and what you have, but just know that the blue box is for those dual fuel applications. If you have an opportunity to use a hybrid Geo system with a fossil fuel furnace, this is a great spot to put that in. Let's say, demand billing, something like that, where you maybe have a really, really low electric rate if you use fossil fuel for a supplement, if the utility company could shut you off or something like that. So just keep that in mind. Go across this top of the page on the Loads tab. This is where I would input my heat load. And again, I'm going to pull up this from another program. This is not from GeoAnalyst. This is from a different program. And I lost my web page there. All right, so heat load 71,077. I'm going to grab this design heating load 71077. My indoor design temperature was 72 degrees. The outdoor design temperature was -15 in that application. I want you to make sure that you put into GeoAnalyst the same number that you put into your load calculation program. So let's take a look here. I'm going to grab another screen. This is a different program, but I want to show you the design temperatures here. So here. And so for this application, I've got -15 for my outdoor temperature. If I select my city, all right, so you can see right here, my manual J load calculation program has given me the option to use 95 degrees as the outdoor temperature for the summertime and -15 for the wintertime. Because those are the numbers I selected in my manual J program, those are the numbers that I want to input for the GeoAnalyst program. So that's what you see here. If you've done a load calculation at -10, please use the -10 number here. The reason I bring that up is because of how the program calculates. If you have any questions, we can talk about that individually. I don't really need to dig into that, but just make sure that you put the same numbers in those boxes. So let's go back to the air conditioning load on this house. Sensible load is 32,662. And the latent load is 11,345. So I'm going to grab a calculator on my desk. 11,345 latent plus a sensible of 32,662 gives me a total load of 44,007. So if you have a program that gives you the sensible number, I would definitely recommend that you put it in there. And if you don't have a program that gives you the sensible number, try to find one. Here we have a heating offset. And the heating offset is basically internal gains. If I have a lot of internal gains, I could slide it to high. If I have very low internal gains, I could slide it to low. I prefer to live somewhere between low and average, just to make sure that I have conservative numbers. If I slide it to high, what will happen is the system will begin heating the home at a colder outdoor temperature. I can show you that in the bin report later. For now, I'm going to put it right at average. So we've input this info. I've checked the constant fan box. I do want to include cooling in this project. If you had some kind of farm shop or job that was only a heating project, you could uncheck that cooling box and then you'd only calculate the heating numbers. Same thing for hot water, but on this project I do want to include hot water, and my temperature would be about 130 with 4 users. So now I'm going to keep cruising across the top of this page and look at the Economics tab. Now the Economics tab, it's going to open up a screen where it's asking you for installed cost, and that's when we realize we don't really know what the installed cost is, so we've got to go back to these buttons. The reason I do it that way, the reason I say it that way or teach it that way, is because essentially you roll right across the top of this page until you get to the economics page, then you have to go down to your yellow buttons. So I've got the heat loss and heat gain put in there. I've got the electric rates put in there. I'm going to grab a geothermal system, system 1. That's going to open a screen for us that will show us some loop options, some minimum, maximum loop temperatures. We can select different machines, and here it is. So for this job, I'd like to do, say, a horizontal bore at 15-foot depth. And here you could select your different pumps. I'm not sure if a lot of people know this exists, but I know the GeoAnalyst is one of the only programs that allows you to go in and input your specific pump for this project. Usually doesn't make that big of a deal, but if you're on an open loop, keep in mind you could go down to user specified watts. And that gives you an opportunity to actually input the wattage from a well pump. Or if you have a hydronic job that has a lot of pumps, you may have quite a bit of pump wattage. So you might want to calculate your pump wattage and input that here under user specified watts, so that you can be sure to log those pump watts in the algorithm and the bin data. For this job, I'd like to select 2 UP2699 pumps. And here we see our pipe type is polyethylene SDR11, and it's 3/4 inch. And our soil type is heavy damp soil. If I want to change those, I could go here to, let's say, the select soil button. All right, now we have ASHRAE soil thermal classifications listed here, which are usually the ones that I select. And here are your different options. Notice that you have thermal conductivity, diffusivity, density, and the specific heat. If you have any of those details, this is where you can try to match up one of these titles with the details that you've been provided. But what I know is that most directional bores in Iowa are in heavy damp soil. So that is the one I'm going to select. I would, I'm just going to make a side note, don't change those run hours. For now, let's always leave those at 300. That basically is 12 days of constant running on this system. So the system's going to run for 12 days straight at design conditions. It's using that 300 hours of steady runtime to calculate the minimum winter loop temp. So that takes us to our next screen here. Entering water temperature. Max summer, 85. Minimum winter, 25. Those are the numbers I like to use. You could put 30 in here if you want. And now we're going to take a look at some different systems. This particular example, we've got Hydron module selected as the brand. At the beginning of GeoAnalyst, I should have shown you, but you could change your brand. Any Enertech brand is listed in here. So for this example, we're going to look at Hydron module, and we have the series. We're going to use the HYT for this example. And I'm going to just try a 4-ton unit on this job. Backup heat will be electric because this is a packaged unit. Hot water heater will be electric with the superheater. And I'm going to allow this to auto-size the ground loop. So let's take a look. What does a 4-ton system do on a 70,000 BTU load? A 4-ton system would have a balance point of 1.1 degrees. So at 1.1 degrees outside, the geothermal system can no longer provide all of the heat that the space needs, and it would have to ask for its supplemental heat to turn on. It's not a bad thing. Take a look at our total operating cost. I'm just going to write it down myself. It's $1,281. The 4-ton system costs $1,281 for heating, cooling, and hot water on this home, as well as constant fan. And the balance point is 1.1 degrees. Our minimum loop temperature is 30. Our maximum loop temperature is 69.7, so we're well under our 85-degree set point. When you look at our total trench required, 998, that's the length of bore. So if I look at that 998 divided by 4, it's asking me to do 250-foot bores on this project if I want to maintain a 30-degree loop. Let's go back and edit the system. I'm going to take a look at this. If I allow this thing to go down to a 25-degree loop temp. Now keep in mind, that is at design conditions. It's -15. The system's running for 12.5 days. We're at the rock bottom point of our ground loop. 25 is the minimum temperature. That gives me a balance point of 2.9. It's not too far off. The op cost there is $13.12. So we didn't really increase op cost much. Let's take a look at our loop length at 747. I'm going to use my calculator. 747 divided by 4 tons. That'd be 186-foot bore. So this is where you look at your loop contractor, or if you do your own ground loops. Do you want to do 200-foot bores or 250-foot bores? However you decide to install your project, you can use this program to help you calculate what's right. I'm going to go ahead and leave it at 25. I'm okay with the 25-degree temperature. My balance point of 2.9 is doesn't scare me at all. So we'll roll with the operating cost of 4-ton system. Op cost is $1,312. Look at this bin data. In the bin data, what it's showing you is the outdoor temperature on the left for the very first column, and the number of hours we spend at those outdoor temperatures. So in this example, let's look at the winter hours. Here we are, we have a building load. The temperature is cold, we have a building load, so we know we're in the heating mode. As the temperature gets colder, the building load increases. Now, this fourth column is going to give you the entering water temperature. And look at here, so the system starts to run, it's on a ground loop, it's taking heat out of the ground gets colder and colder as the season moves on. But here we are at our rock bottom temperature. Again, this is actually more than extreme design conditions. So when I come to the bin data, the most important thing I look for is where does the auxiliary heat fire? And here I'm showing 0, 0, 0 all the way down to here, and I'm burning aux heat at about 2 degrees. So in the 2-degree bin, I start to log some aux heat hours, and that's reflected up here. 2.9 is our aux heat balance point. So you can see it right here. How many kilowatts a year do I spend on electric heat? 779. So if it's 779 kilowatts and I'm paying 10 cents a kilowatt, I'm actually only spending $77 or $78 on electric heat with this 4-ton example. Keep that in mind. $78. I'm going to write that down as well. $78 OGS heat. So I'm going to go back to the project page. And I'm going to look at a 5-ton system. What will a 5-ton system do for this house? Now we're going to pick all the same numbers. Horizontal bore, it's going to be 15 feet deep. My pumps are 2 UP20 699s. My pipe is 3/4 inch SDR11. I'm in heavy damp soil. My maximum temperature, 85. My minimum temperature, 25. I'm going to pick an HYT unit. And this is going to be an HYT 060. So now we're looking at a 5-ton system. Again, backup heating is electric. Hot water is my, electric is my hot water. I'm using it as superheater. I'm letting the loop auto size itself calculate. And let's see what a 5-ton unit can do. So the balance point's lower. I see that right away, negative 6.1. So that gives you more geothermal energy out of the ground loop. Let's take a look at the op cost. It's $11.83. So that's our 5-ton. And back here at auxiliary kilowatts, I've consumed 199 kilowatts of auxiliary heat. So 199 times 10 cents. This project is actually only going to spend about $20 on aux heat. Now, go back to the project page and take a final look at the 6-ton system. Horizontal bore, my depth is 15 feet. My pumps are 2 UP20 699s. My pipe is SDR11, that's 3/4 inch. My soil is heavy damp soil. Max temp 85, minimum temp 25. We will do an HYT unit at 6 tons. So we're reaching out for that HYT 072. Again, backup heat is electric, hot water is electric, and I'm auto sizing the ground loop. Let's calculate this one. Which one is the right size system? I've got op cost here at $1,216. And my balance point, notice this, I'm all the way down to negative 12.9. So I don't expect to see a lot of kilowatts here. Actually 42 is what we've got. So if anybody wants to take a guess, we've got 42 kilowatts of aux heat, so he's spending $4.20 on electric heat if he buys the 6-ton system. So the reason I'm going through all this is I just want you to understand that a lot of times I hear contractors say, well, my load is 70,000 and negative 15. If you're selecting a furnace, you would select a furnace that would give you that 70,000 BTUs of heat. But with geothermal, we have the heat pump harvesting energy from the earth, and we have the electric supplemental heat. So we're using them as a team to get the total number of BTUs. And we don't need to purchase the geothermal system that covers that load 100% because the auxiliary heat really doesn't have that large of an impact as long as you get down to close to zero with a balance point. So we know that those three things are calculated. I'm going to go back to the project page. I'm going to go and look at the fourth system, which will be our propane example. Select the most efficient propane system with an ECM blower and give it, say, a 14 SEER AC. 3.5 tons might cut that AC load. Hot water will be propane at an energy factor of 0.59. If you guys want to change any of this stuff, you could always pick a tankless water heater or whatever you want to pick. I just want to keep our example simple for today's discussion. So we calculate this and we see that the operating cost on the propane system is actually $2,156. And again, we see some bin data from that system. So now I can go into the economics page. I've calculated my systems. I know that system 1 is a 4-ton system. I'm going to put that at, let's say, $20,000. I'm going to put the 5-ton system, let's say at $25,000, and the 6-ton, let's say $30,000. A propane system, propane furnace, 14 SEER air, you might be at, I don't know, $8,000 or something like that for that system. And I'm going to leave energy credits out. We are trying to extend the tax credit. We do have tax credits in Iowa. We have a 10% state credit. There's utility rebates you could put in here. But I want to keep it simple right now and just show you the installed cost versus op cost. So what we're looking at here is a comparison of these different systems. So let's compare the 3 geo systems head to head. Looks like the internet's a little bit slow today for some reason. This is a web-based program, so if you're out in the sticks trying to use this on your computer or the phone, maybe don't. So what we're seeing here is that I've selected a 4-ton system as system 1, a 5-ton as system 2, and a 6-ton as system 3. You guys know the op cost. The operating cost for the first system was $13.12. The second system, it is less. Look at this. I mean, it costs $11.83, so that's the most efficient system. But they paid another $5,000 to get that system and avoid spending $78 on electric heat. So they spent $5,000 up front to avoid spending $78 a year. It doesn't really make sense. The payback will never happen. So we'll scratch those and say that the 4-ton system is actually the proper system for a 70,000 BTU load in this example. Now we've got a propane system here as the 4th column, and the op cost for the propane system, $2,156. In 13.99 years, you would get your payback with no incentives. So that is no rebates, no credits, nothing. In another way to say this, everyone, is that in 14 years, if you pick a propane system to keep you comfortable, in 14 years, you will have given up all of the money that you would have spent to buy a geothermal system, and you still won't have one. So you're going to buy it anyways. You're just giving the money to the propane guy. And actually, at about 14 years, you could be in the market for a new furnace. It might last a little bit longer, but it's just not a good decision. Now, if we bounce back to the economics page and if we consider some incentives, let's take a look at that. A $20,000 install project with a 10% tax credit, they're going to get a $2,000 tax credit. And let's say they get $1,000 from the utility company. That's a pretty low number. So here in this example, we have a $3,000 total incentive. And let's take a look. 10.5 years on that example. And that's $1.30 propane. If I go back into the utility rates, that's 10.5 years at $1.30 propane. People think they're getting a deal at $1.30. Well, what happens if your propane rate goes to $2? I used to burn propane at my house. It was $2.30. So I don't think $2 is a very outlandish request or a very outlandish number. So here now, if we're looking at $2 LP, the payback is only 4.89 years. So you can see all these different variables: the size of the system, the installed cost of the system, what is the propane rate, what is the electric rate, do these folks get a discount on their electricity? In Iowa, some utility companies will sell you electricity for a nickel a kilowatt. Others are at 14 or 15 cents a kilowatt. So you have to be careful with, say, throwing payback numbers out there. You can see I haven't changed the example here at all. I've just changed what happens to this homeowner's electric rate, and the payback has changed significantly. So just always keep that in mind. Yeah, we're going to skip that page. We'll go to the graphs page out here. Now, one important thing for you to remember on the graphs page is always check total cash flow and cumulative cash flow. This is the chart that will show you the payback of your system. So here, remember, this guy got a 10% tax credit. He got a $1,000 rebate from the utility company, and we're comparing against $2 LP. But his payback was right there where those two lines intersect. If I go back in here, I'll show you this. Hopefully the program will cooperate with me here. Take him back to $1.30. And again, click total, cumulative. And for some reason, it always ends up doing that to me. I think I have to recalculate the cost summary page, I believe. In order to get the graph to update, one of these pages has to be refreshed. I think it's that one, so let's try. Oh boy, sorry guys. I unchecked that system. Okay, now we're ready. There you go. So notice how the graph did not refresh because I didn't go back to that page and refresh the calculations. You don't have to go back through system 1, 2, 3, and 4 to recalculate. You just have to go back to the economics page, uncheck the comparison box, and then recheck the comparison box. Then it will recalculate all your digits. So in this example here, he's $1.30 propane versus 10 cents for 10 cents a kilowatt for electricity. And this payback here is looks like right about 7 years. So then we go on to print these reports. I've given you guys more information than your typical homeowner would really want to see. What I like to do for the homeowner is I like to give them a title page and these summary pages. And actually I'm gonna, if you really want to, you can, what I have always done is printed these bin reports and pulled them out, set them aside. I only show the homeowner the summary. If they want to get down to brass tacks and they want to say, well, this other guy quoted me a 5-ton, why are you at a 4-ton system? Then I could pull out the bin data or the summary from the other systems and show them the details. But I like to keep the bin reports off the table because it really just muddies the water for people. It's very confusing for a general homeowner to look at that info. So we'll go ahead and print the PDF. What that's going to do is open up another little PDF screen here. We have a GeoAnalyst example. I've got the branded equipment brand here, and this logo is actually something I've put in there. You can put your own company's logo in there so that you're branded on this report. So we get a nice little title page. Here's a summary report for System 1. You get a lot of details on this page, but here is the bin data page. So this is the one I'm telling you to leave alone. Don't show the homeowner this unless you have an engineer or someone who really wants to get down to brass tacks on the digits. For the most part, your summary page is plenty of information for most people, actually really too much. I like to focus on the op cost screen, op cost window right here in the green box. So System 1, we have these op costs. For you folks that are on the webinar, I'm going to go ahead and just breeze through some of this stuff here. Zoom in a little so you could see it better. So we have our annual heating load. So for the year, that's how many BTUs. This is the electricity that the geothermal system consumes. This is the electricity that Augs Heat consumes. The percentage of the heat load by the geo system is 97.2. The average COP is 3.46. That is actually blending in the auxiliary kilowatts and calculating those into the COP. So it's not just your AHRI COP or your engineering data COP. This is actually being penalized because of the auxiliary heat kilowatts only running at a COP of 1. And so the annual cost there for heating is only $790. You get the same kind of info for your hot water. your cooling. If you want to, you can get into, maybe I take a highlighter and highlight some of this stuff on a piece of paper, show the homeowner, okay, so, you know, you remember that program that I used to show you your heat loss and heat gain was 71,077, and so I took that number and I input it into this program right here. That's at 72 and negative 15. Here's your electric rate, and here's your air conditioning requirements, conditions, and also the rates. You slide down here. This is your a little bit more detailed info. Aux heat required, emergency heat required is 18.75 kilowatts. Let me make a point real quick. Go back to, let's say, project page. I want to show you something real quick. I was in a class and the guy was pushing to size a job like this. You see the emergency heat requirement is 18.75 kilowatts. So this one fellow would select a 20 kilowatt heater for that job. And he says, I would pick a 20 kilowatt heater for this because if something goes wrong, you always want that emergency heat to keep the house warm. I disagree. I believe that that's like putting a furnace next to the furnace that you just installed in case the first furnace doesn't operate. This is a little bit redundant for me. I only need that electric heat for supplemental heat. So let's go back and take a look at GeoSystem 1. What do I need for auxiliary heat? I do not want to select an aux heater that is based on the requirement for emergency heat. I only want to select an aux heater required to provide supplemental heat. So here are these two differences. On my left screen, I have 7.77 kilowatts required for aux heat. So I would select a 10 kilowatt heater on this job, 4-ton unit, 10 kW heater, not a 6-ton unit with a 20 kW heater. The reason I'm saying this is because we don't have a tax credit, and if guys are still out there quoting projects that are 6-ton units with 20 kW heaters, they're probably not going to sell them because that's another $10,000 just for the Geo system, and you may have to force an electric upgrade to supplement or to provide the 20 kilowatt supplemental heater. So this is the most important point I really wanted to drive home with the webinar, is that just because the heat load is 70,000 BTUs doesn't mean you need to select a Geo system that provides 70,000 BTUs from the dirt. We can use the aux heat. We can still have a very economical system, and it actually is a better purchase for the homeowner because they're not spending $5,000 or $10,000 just to save a few. So we're going to be wrapping up here shortly. I wanted to just scroll through a couple of these with you. Bin data report. So here again, it's notice system 2. You get all those same digits. Here's your ground loop information. Bin data, system 3, same digits, bin data, and system 4, your propane. So for this homeowner on a sales call, what I would do is just show them system 1 and system 4. I would keep system 2 and 3 in my bag, ready to show them if they ask the question, why did you pick a 4 and the other guy picked a 5 or a 6? You can real quickly lay it out there and show them that you've done your homework, this is the proper system, and you can show them exactly why this makes the most sense. So really that's the point I wanted to really drive home for you guys. So I think I'm going to wrap it up there because we're pushing 9:45. It's 9:42 right now. So I'm going to go ahead and open it up for some questions and answers. Noah, could you go ahead and unmute the attendees and see if they've got anything to ask, or if you have questions that you've typed in, Noah, or that anyone's typed in, let's go ahead and review those.
All right, all the attendees are unmuted.
Okay.
Jason has a question here.
All right.
Oh, sorry. Did you guys read my question?
Yeah, I'm reading it right now.
Okay. The question, just for everybody, is when we go to apply for our geothermal permits here in Alberta, we have to show that the heat pump meets at least 85% of the capacity of the heat loss. And so even a 4-ton, you know, if I was looking at GeoComfort GXT in the manual, I think it provides something like about 38,000 BTUs at 30-degree incoming water temp.
Right.
So we can't install a 4-ton on something with a 70 or 72,000 BTUs because they go by capacity, not by the annual heating, like I see what you've highlighted there.
Yes, sir.
We actually have to show that capacity meets 85%. So we have to put in a quite a bit bigger system. Do you guys have that down in the U.S. at all?
We do, actually. In Iowa, there's a co-op that requires the same thing. They require an 85-degree temperature difference for your calculation, and that you provide 85% of those BTUs looking at your bin data, or looking at your engineering data is what they typically use. So if you're looking at let's say you're saying GeoComfort, so a GYT unit, if you pull up the EDIM for that unit, you're going to look at the engineering data, and you have to go all the way through all of that, basically make your own case to the utility company and say, here's my load calculation at this many BTUs, and here's my engineering data that shows this machine provides 85% of that requirement. It would be nice
so
to.
For a GYT, it's 53,000, so technically we still can't install that.
Yeah.
So just something I thought I'd bring up. I don't know if it's different here in Canada, but.
Yeah, we experience that down here. What I find is that a lot of the utility companies, if we actually work with them, they will maybe make exceptions or change their tune, if you will. The only way that I could see you even making a case there is if you were to go through these reports, maybe have one of us help you go through this and show them that it actually, because the whole reason that they're requiring that is they don't want those aux heat kilowatts.
Yes.
You know, that utility company says, I cannot afford to have everyone on these power lines burning aux heat when it's negative 15 outside. We can't do that. And so if we look at that, we'd show them, okay, here's, you know, this is where they're worried about. Basically, these folks are burning kilowatts here, and they don't want those kilowatts.
Yeah.
I mean, so the only case you could make is to grab these 3 reports, you know, the 4, 5, and 6-ton system, and compare them and show them how much they're actually talking about, because I don't know that they really fully comprehend maybe they do, and I'm totally wrong. I have been wrong before.
No, I don't think that they do, but I also know that it is right in their requirements that we have to supply the manual. We have to point it out to them. So we generally just put in bigger. We have a much longer cooling season as well. So, heating season. So we're usually a little bit bigger.
Yeah. Yeah, that's a great point, because we do experience that here in Iowa, particularly southern Iowa.
Mm-hmm.
So, I need to close that out. But yeah, unfortunately, that's going to force your install cost up. I mean, that's what it does. It makes it harder for you to sell geothermal up there. I mean, with your extreme weather, maybe it's still. What are you paying for LP up in that area?
In Alberta, we have very little, if any. There's the odd one, but I don't think in 7 years I've ever changed out one from propane to geo.
So if people are burning fossil fuel up there, what is it? Is it gas?
Oh, natural gas. Yeah.
Yeah. So you have to install large geothermal systems, and you compete against natural gas. What's the rate for gas?
We are about $1 a gigajoule.
Uh-huh.
So it's pretty low up here, because we obviously, Alberta has a ton of natural gas, so it's still fairly cheap up here for natural gas.
Mm-hmm. Yeah, that's a great point. And you can run it right through here. You know, you can simulate all of that different stuff and look at how
I've
it
always
affects.
had a hard time putting natural gas into this GeoAnalyst because of the conversion from, you know, we pay by the gigajoule here, and then you got to either convert it to whatever that is, cubic feet per meter or something like that. I don't know. It's been it's been hard to figure out the calculation to convert that.
Yeah. Well, we can help you do that. We can help you get something figured out there. I know that down here they sell by therm, and that CCF is cost per cubic foot, which is, I had to look that up once. But there's calculators online. If you're getting, you know, sold per therm or, you know, some other kind of different unit, you can use a calculator and convert those. That's how I have to do it. Noah, did we have any other questions pending?
I am not seeing any other questions. We're getting close to 10 here, guys. Do we have, are there any more questions you guys need to ask right now?
If you guys want to have some other conversations on the side, feel free to call or text Inside Sales Department, chat with any of the folks in there, or if you want to talk to me, they can pass you right over to me. So,
absolutely, we're always here to help you if you got any questions, and if we can't get that answer for you right away at Inside Sales, we'll get you connected to who will. So we'll make sure you get taken care of. Absolutely.
Yeah. Yeah, make sure you speak with one of us on a side conversation about this, or we could do a little private webinar and go through it with you and just run these examples and try to find you a conversion calculator, or we could even have the program updated to include your unitary cost. That's something
that'd
possibly do.
That'd be great for all my dealers up here in Canada. I think that's how we sell most of it. So perfect, great, thank you.
Yeah, make that push. Get a hold of one of us and make that push, and we'll try to make that happen. Well, thanks for sitting in, everybody. I appreciate your time today, and I hope that you learned a little bit from this example. Next week, we'll be on the same bat time, same bat channel. Next webinar, we'll actually be selecting your pump. So I'm going to go through some different pump options and show you, different ground loop selections, some variable speed flow centers, constant speed flow centers, stuff like that. So stay tuned. I look forward to talking with you guys next week. Thank you.
Good, thank you.
Thanks, Jeremy, and we'll look forward to seeing you guys next week. Again, let us know if you have any other questions that come up. We are more than happy to help you. So it'll be, our email is insidesales@enertechgeo.com, or you can call us at 618-664-9010. All right, everybody, have a good day. We'll see you next week.
Thanks, everyone.